Hello everyone, I'm Sam, and today I'm going to show you some ways about detect virtual machines in Android, and I will also show you about how to bypass those detection techniques. Before we start, I have to mention that this is my GitHub, and I will put an APK here. I do write some code in this APK, but I do copy it from here. I do copy several, maybe like 10 detection code here, and thanks to this author. My APK can detect like 19. Can using 19 techniques to detect virtual machines, and let's just take a look about how it can detect virtual machine and about how we can bypass those detections. Okay, let's first take a look at this device ID. Let's read the source code about how it detect those virtual machine. Okay, here source main VM test utils and device ID. Where it is? Okay, here we see here how the API to use is actually in telephone manager get device ID. So how can we bypass this technique? It's just that some virtual machines have some default device ID, so we can use that to detect virtual machines. Like these are some known device IDs. So if the machine has this device IDs, so it might be in virtual machine. Okay, how we can we bypass this? We all know that it uses get device ID, right? So and it's in the telephony manager. This might be a Java file, might be it is a class, and it might be a Java file. So where it is? Basically, we have to find it here. This is the Android source code. So how can we find this get device ID here in the Android source code? So if we don't know, we can just search it, right? We know that this telephone manager, right? So we search Android source code telephone manager. Okay. It shows telephony Java Android telephony. Oh, it didn't show actually. See, just click it. That was very slow. Android platform frameworks. Okay, base. Okay, let's see. Frameworks base and the framework base. Let's see. It might be this telephony Java Android telephony. Okay, we see those Java files, right? Okay, here let's see telephone manager is here. So we have to see the right. We have to see the get device ID. Just search it. Get device ID. Okay. Oh, sorry. Device ID. Yeah, here we saw it. So how can we bypass it? So basically, it actually go to some like telephony get device ID. It's another API. It's I think it's here, right? It's this one. It's not this one. Get device ID. Oh, it's just this one. Yeah, the one below. So for this one, if we just dive into this one, we may go to somewhere else. Like we can go to like some native code below the framework. Yeah, but we want to save some time, so we need to change this framework code. Like we see that it has this try and catch. So if we just comment this out and we just return something that we want, it will works well. It works well. It should it works well. Yeah. So how we can do that? It's just yeah, I want to show you how we can do that. Framework. Okay, framework and the base telephony Java Android telephony. Okay, telephony manager with Vim. Yeah. Let's get to that function. Okay. So if we see here, it's like 860. Okay, here. This function, right? Okay, as I see, we want to do this. Okay, dash. Okay, come this out. So we just return point. Okay, if we just return point, it works well. So if you just compile the source code right now and start the emulator, and when you call the get device ID, it will give you point instead of the real device ID. So yes, this is the way that we can bypass the get device ID. Yeah, this is one detection, and we can see that there are other detection like get device ID, and we see this some known numbers because it's also like a function in telephony manager, right? And like this known IMSI IDs. Oh, it's also here. So they have the same way, same way to bypass them, and yeah, you can just do what I just did and to bypass these techniques. Also, I want to show you another one, like yeah, just okay. Let's take a look at these QEMU pipes. Yeah, but actually for some emulators it has they have this devices virtual device here, and but for some emulators they don't have these pipes. So what I did to bypass it actually because we see it has a new file pipe to detect whether this device exists, right? So if we just change that file.java, change that to bypass this pipe. So what I mean is actually like source. Let's see where it is. Source. I think it's in there. I can't remember. Yeah, I think it's here. Zipcoin and GUI source main Java IO. Yeah, here. Yeah, and the file.java. I think it's in the file.java opque. Okay, file.java. Okay, here. So what I mean is for this kind of detection techniques, we can just go to file.java, and it has some, I think it has some construction. functions, right? Let's see. Okay, yeah, it's here. You see this this function file. So when you use this use this class, it will call this like this function file. So for in our case, when we use new file pipe, we input this string like device socket QEMUD, right? And it will call this function public file string path name, right? So what you have to do is like you detect whether like the path name is dot equals like something like this one, device socket QEMUD or device QEMU pipe, device QEMU pipe, right? So if the path name equals this one, so the framework knows that the APK might be detecting whether it's a virtual machine. So in this case, we can do path name equals like what? We just give it a random name, device SAM. So we all know that this device is not in the virtual machine, but yeah, unless you want to create a drive named SAM. Yeah, but in our case, we are not going to create that driver, so the path name will be device SAM and it won't be there, so the file cannot open it, and we can bypass this this detection technique. Yeah, and yeah, that's what we did to bypass this kind of detection techniques. But actually, you can do that in the native layer, and you can change that maybe in the libc. So, but I do doubt that whether we can do that, because if we change the libc, the system might want to communicate with the QEMU pipe, but since we changed the libc, it cannot detect that pipe. So yeah, that's quite confused. If you want to have a try, you can change the libc, yeah, and the native code. But then here I just do that in the framework. Okay, yeah, and this is this kind of how we can bypass this kind of detection. And I think there are some detection techniques that is the same. Let's see where it is. Okay, not this one. Yeah, yeah, here this one. I think this one. Yeah, you can just see this new file. And yeah, QEMU files and Genymotion files. Yeah, you can change the new file to the file.java to bypass these techniques. And also, I want to show you another way to bypass, like for this one, ptrace, right? So you have to I assume you know about what is a tracer, what is ptrace. So I'm not going to talk about that here. So yeah, you can just search the internet about what is ptrace and what is a trace ID, trace PID. So yeah, why not just take a look about this trace PID? Okay, I've got a virtual machine here, like I use 8dB, and in the process I got this one. Okay, so let's just go to process like 2117. here we got this, and what we see here is status, right? Cat status. Yes, so what we have here, yeah, you see this trace PID, right? So if there is so if this process trace the trace PID might not be 0, it might be some other number. So if it's not 0, the process no is traced, so it might be in a virtual machine or something. So yeah, so how can we bypass this? To bypass this, I think can we do that in framework? Let's see, a new file. Yeah, maybe you can do that in the framework. Just change this file, this Java file. Yeah, you can probably change that to bypass, but no, but I'm not going to do that. I want to change it in the kernel. Yeah, and we can compile the kernel ourselves. So I'm not going to show you how can we compile it here, because it really takes a long time, and the Android source code. If we also if we want to compile Android source code, it may take you like one night. Yeah, and that's quite a long time. But when you compile it for the first time, the next time it will take you less time. Okay, so here let's see the kernel, Goldfish kernel. We are here at the root directory fs process array.c, this file, and we see this function text state, and we see that sequence printf here. Yeah, this is basically what we get from this you see here, state right, tpid right, okay, trace PID. So what you want to do is make that trace PID always be 0. So yeah, how you can do that? Think is seq printf. So you can do this. This is tpid, right? Let's show you. You can just give it a constant instead of a tpid, because you will go to somewhere else to get that PID. So you just do this one. You see tpid, the range one is ppid tpid, right? So all you have to do is give it a constant like 7. Because you have to give it 0, but if you want to say that you actually make some change to the kernel, you can give it to 7, and you compile the kernel and then start the emulator. You will see that our process has a trace ID as 7. So in the real world, if you want to bypass this, give it 0, and everything. Every process will have a trace PID as 0, even if they are traced. Yeah, this way how can we bypass this one? Let's see how it's 18 minutes. Oh, we can still. I think we can still give one more example. Yeah. Yep. Oh, I think this example is enough. But I do have to talk about this anti-VM APK. Yeah, we have some, three. I think 3. Yeah, these 3 techniques. This it's very hard to bypass these 3 detection techniques. I'm not. I don't know how to bypass them, because and I asked my mentor, and he said it's very difficult to bypass them. So if you know how to bypass these 3 techniques, just leave a comment below, and let's discuss about this. because I think this QEMU task is for this one is some kind of QEM properties, and for this SMC detection, it's based on Harvard architecture for ARM processor. So it's really hard, and even so for this breakpoint detection, it's just because that the QEM get locked or quit abnormally when we call BKPT in the ARM assembly. Yeah, it's quite hard. Also, one thing to mention that if you want to run this APK, especially for these three detection techniques, you have to build an ARM image instead of an x86 image, because we have some ARM assembly code in this APK, so you have to use that. You have to use the image should be ARM instead of x86. Yeah, I think that's all I have to mention. Yeah, thanks for watching my video, and if you have any questions, just leave a comment below, and I think I will answer if I have time. And yeah, I also really have very bad English, so yeah, thanks for watching.